Characteristics of biochar. Biochar is a process medium rather than a result medium. This is what I always say. In the presence of biochar, so many things happen. It is not that which is consumed and producing result. It brings that synergy, and this particular material is the most wonderful material that is existing on this earth, because it is helping all the environments, physical, chemical, biological, within the soil ecosystem and beyond, is addressing the environmental, ecological, climate change, mitigation, and many more things. However, testing the chemical composition of biochar as the result medium is easier than estimating and appreciating the real value of the functions biochar performs in space and over time. Say one has gone for the approximate analysis, one of the basic tests for biochar. Here what one would understand, they would understand only the calorific value of that biochar, but here we are not combusting. Or they might understand what is the fixed carbon. That's a good indicator that tells about long-term benefits of this carbon in the soil, say 100 years to 1000 years. So that values which are related to carbon sequestration, this kind of understanding generally. But otherwise, the real values of biochar, while being in the various environments, this aspect is not so easy to put in a report form. For example, evaluation of a process medium could involve measuring the moisture retention in the soil, the extent of aeration of the soil, the level of absorption of harmful pesticides and chemicals from the soil, speed of the release of nitrogen into the soil, level of absorption of greenhouse gases from the soil, temperature regulation in the soil. So these tests nobody does comprehensively. The level of absorption of harmful pesticides and chemicals from the soil, speed of the release of nitrogen into the soil, level of absorption of greenhouse gases from the soil, temperature regulation in the soil, and the quality of habitat created by biochar for the thriving of soil microbes, among other variables. To understand biochar, one needs to conduct an experiment. Take 4 pieces of land with the following compositions: soil and biochar, soil, biochar, and amendments. Then soil and amendments. Then control soil. Amendments include compost, farmyard manure, or chemical fertilizers, even organic, inorganic, all kinds of additives which are usually used in agriculture. The set of amendments which a farmer is intended to supply or regularly what they use. So those things need to be added as part of amendments. Then sow seeds on each piece of land and monitor the following: germination, height of plants, number of leaves, development of flowers and fruits at regular intervals, and also ultimately measure the yield also. These observations will be more meaningful than testing the chemical composition of the soil, because it is the characteristics of biochar that matter in gauging its value. Carbon. An argument is often put forward that biomass is or its different form should be returned to the soil. However, the benefits of compost and biochar are not the same, even though both are derived from the same biomass. Compost is food for soil life and a source of nutrients and minerals for plants. The benefits of compost just last for a few years, say 1, 2, 3 years, whereas the benefits of biochar last 100 to 1000 years minimum, and also enhance the value and benefits of the compost that is applied along with biochar exponentially. Here, let us calculate in 1 hectare of land, that is 10,000 square meters of area, having a soil that is about 33.5 centimeters deep with a bulk density of 1.4 tons per cubic meter, soil mass per hectare is about 4,700 tons. If we take only 4 inches, 5 inches depth of soil, then the quantity of the weight of the soil will be less. If appropriate management practices were adopted and these practices achieved and sustained, there would be a 1% increase in soil organic matter, working out to about 47 tons of soil organic matter per hectare being added to organic matter stocks held below the soil surface. These 47 tons of soil organic matter contains approximately 27 tons of soil carbon, that is 58% per hectare. In the absence of other inputs, soil carbon may only be derived from atmosphere via the natural function known as photosynthesis. To place approximately 27 tons of soil carbon per hectare into the soil, around 100 tons of carbon dioxide is consumed out of the atmosphere by photosynthesis. Therefore, a 1% change in soil organic matter across 5 billion hectares will sequester 500 billion tons of physical carbon dioxide. Here we can see the calculations. Every 1% increase in retained soil organic matter within the topmost 33.5 centimeter of the soil would capture and hold approximately 100 tons of atmospheric carbon dioxide per hectare. The variability in the equation being due only to soil bulk density. 1 ton of carbon dioxide contains 12 by 44 units of, that is, carbon, that is around 0.27 tons of carbon per ton of carbon dioxide. Therefore, 27 tons of carbon sequesters. Therefore, 27 tons of carbon sequesters 100 tons carbon dioxide. What is soil organic matter? It is the plant material released into the soil during the natural phases of plant growth. It includes root material plowed off below the soil surface, plant litter carried into the soil by microbes, insects and rainfall, or during the ploughing. Soil carbon is the elemental carbon contained within the soil organic matter. Broadly, soil organic matter is from plant material as well as from other life also, say microbial life, protozoa, nematodes, arthropods. So, various other things also contribute to the soil organic matter. Compost is one such beautiful material that is directly relatable to soil organic matter. Carbon atomic weight is 12. Oxygen atomic weight is equal to 16. Therefore, molecular weight of carbon dioxide is equal to 12 plus 16 plus 16 is equal to 44. As more compost and mulch along with biochar are added, the activity of microbes residing in the charcoal or biochar increases. The microbes use the soil organic matter as food. Overall, the carbon content of the soil improves due to the biochar and increased soil microbial density. Here, the fixed carbon, that is biochar, when it is added, that is going to remain in the soil, that is one carbon that is being stored permanently. Means about 100 years to 1000 years. So, this is one carbon. Another carbon is in the presence of biochar or within the soil, soil organic matter from various sources that is existing. Traditionally, the soil organic matter which is existing in the soils is very less. But in the presence of biochar, due to microbial activity, due to enhanced production, due to the great growth of the roots of the plants, and due to changed ecosystem of the soil, the total soil organic matter over a period would also increase. Therefore, both the biochar, the soil microbial activity, and the total biomass that is existing within the soil, everything contributes to the soil organic matter. Lehman, a great soil scientist and one of the pioneer researchers in the field of biochar, he estimated that a total of 9.5 billion tons of carbon could potentially be stored in soils by the year 2100 using a wide variety of biochar application programs. Once equipped with a better understanding of this potential synergism and the mechanisms that drive it, biochar could be used to sequester carbon in soils, thus contributing to climate change mitigation. This interaction could also be harnessed for the restoration of disturbed ecosystems, reclamation of sites contaminated by industrial pollution and mine waste, including fertilizer use efficiencies, with all associated economic and environmental benefits, and development of methods for attaining increased crop yields from sustainable agricultural activities.